For all the latest updates, subscribe to News9.
Navigating through the vast cosmos can be quite challenging with millions of celestial objects on the way and lack of galactic roads. However, scientists of NASA have come up with a solution. NASA scientists are developing a new navigation system designed to help future space travelers find their way in the universe and reach distant destinations such as the Moon and Mars. The Galactic Navigation System will use the guiding light of pulsars, a type of star that acts as a cosmic lighthouse. Pulsars are fast-rotating neutron stars or the dense remains of a star that exploded in supernova. These stars emit electromagnetic radiation in the form of bright, narrow beams that sweep across the cosmos in a circular motion. From a distance, the stars will look as though they are pulsating in flashes of light, hence the name pulsar. NICER, an X-ray telescope on the exterior of the space station, collects and timestamps the arrival of X-ray light from the neutron stars across the sky. The software installed in NICER called Sextant will then use the beacons from the pulsar to create a navigation system. The concept, referred to as XNav, could provide autonomous navigation throughout the solar system. Researchers say that the GPS uses precisely synchronized signals. GPS uses precisely synchronized signals. Pulsations from some neutron stars are very stable, some even as stable as terrestrial atomic clocks in the long term, which makes them potentially useful in a similar way. Navigation information provided by pulsars does not degrade by moving away from Earth, since pulsars are distributed throughout our Milky Way galaxy. The stability of the pulses allows highly accurate predictions of their time of arrival to any reference point in the solar system. Scientists have developed detailed models that can predict when a pulse would arrive at a specific point. Timing of the arrival of the pulse to a detector on a spacecraft in comparison with its arrival at a reference point provided information for navigating far beyond the planet. Pulsars can also be observed in the radio band. Unlike radio waves, X-rays are not delayed by matter in space. In addition to the delay, the detectors for X-rays can be more compact and smaller than radio dishes. As X-ray pulses are weak, a system must be robust to collect a signal which is sufficient for navigating. Scientists say NICER's large collection area makes it ideal for the research. NICER is roughly the size of a washing machine, but you could dramatically reduce its size and volume. For example, it would be interesting to fit an XNav telescope into a small satellite that could independently navigate the asteroid belt and characterize primitive solar system bodies. In a paper published in 2018, Sextant has already successfully demonstrated real-time pulsar-based navigation aboard the space station. Sextant also studies the use of pulsars for timekeeping and clock synchronization. Researchers said that astronauts could potentially use the Sextant as a supplement to on-board navigation capabilities in case the astronauts have to make it back to Earth on their own. Gateway's orbit around the Moon of approximately 6.5 days would let us stare at pulsars for much longer times. That's where the trade comes in. The instrument is like a bucket, and you're filling that bucket with enough X-ray photons to generate a measurement of when that pulse arrived. You could have a detector a fraction the size of NICER. The experiments could make the use of cosmic lighthouses to guide spacecrafts to their destination a step closer to reality.